The series of short videos cover property predictions of chemical system. First, in the series, we will start with pure component properties predictions of organic chemicals and polymer lipid units. The second, we will cover mixture properties of organic chemicals. And the third, we will cover on the predictions of inorganic salt in aqueous electrolyte system, phase diagram of non-reactive reactive system, and also solubilities. Properties, as we know, play a very important role in the process as well as product synthesis, design, analysis, and application. In this video, we briefly highlight the feature solid solubilities to selected two spark of ProCAPE. However, we will start a brief overview of solubility's function for inorganic salt in aqueous electrolyte system and phase diagram for reactive and non-reactive system. With this background, we will start the demonstration of electrolyte system, then phase diagram for reactive and non-reactive system, and then solid solubilities. So let's get started. Property estimation for electrolyte system.
As same as before, only 4 steps are included for the property estimation. In this part, the property predictions are solubility products, solubility indices, pH value, and plotting graphs such as solubility curve. The example after this will be presented for showing on how the electrolyte mixture in Reactive will help user to solve the problem. This one aqueous mixture of the following salt, sodium sulfate and glucose salts. The questions are how to extract the glucose salts and what should be the design of the crystallization process. First, we need to go step by step, starting with adding the compound into the system. In this case, water, sodium sulfate, and glucose salt are added. And then the parameter of configuration are added. Following this, after that, the property prediction are selected. In this case, the solubility indices are selected and the solubility curve are generated. After complete filling of the information, this result will be presented. The solubility indices shows the glucose salt already formed crystals. So if the temperature a bit reduced, it will be precipitated. For the salt solubilities diagram, this can indicate that which point can get the glucose salt at the solid pure. You can further draw the line to complete all the phase diagram, and you can get this picture for the whole system. And also the crystallizer design can be checked by another program called ICAS. So after putting all of the information and run it, this simulation can be checked whether the correct salt are precipitated. So up to now you can understand and know on how to help the electrolyte mixture function will be applied with the problem solutions. Then we will quickly show you on the software, and we will show this example to you for the explanations.
Okay, so now here is the property estimation for the electrolyte system. So these two will provide the property resolve of inorganic compound in water. I will start with producing the phase diagram for the ternary system, which is the system that consists of water, the potassium chloride, and sodium chloride. So first, so the step in here will be similarly with the organic system feature that I have demonstrated before. Step 1 is the compound selection. So first, I will just change the database to solve database, which is the database that have a lot of the inorganic compound. And then I will add water and click add. And next is sodium chloride and add. Another is potassium chloride and since it is electrolyte system. So this box need to be checked, and this box is very important. So whenever user consider the electrolyte system, you need to check this box. And then I will click OK. And if I try to open it again, you will see that there are multiple ions that have added depending on the selected compound. Because even though the main components are water, sodium chloride, and potassium chloride, some extra compounds should be included in the component list since they might precipitate at the various temperatures. And these extra compounds are the double salt of the two single salt or the dehydrate or monohydrate. Okay, and then I will continue to step 2 for the electrolyte configuration. So after the compound are selected, the stream and condition can be defined in here. User need to specify stream condition and flow at the same. And if I go to unit configuration, the various units are available to be adjusted. So if I would like to change temperature to Celsius and mass to kilogram, and if I go back to parameter configuration, you will see that now the unit is changed according to the unit that I have selected in the unit configuration. And then I will change temperature from 300 to 100, let's say, with the same pressure at 80 kilogram per hour of water, 15 kilogram per hour of sodium chloride, and 5 kilogram per hour of potassium chloride. And then click OK. And next, so this step is step 3, the property prediction. Before select the property at the same, I will go to property model and click default and click OK to set the property model to work properly. And next, select the compound that needed to be considered. So I will select water, sodium, and potassium chloride. And then I will select solubility curve with the triangle. The x-axis will be sodium chloride. The right is potassium chloride, and let's say the top is water. And due to we going to plotting the multiple curve for the multiple curve of solubility, so in here I will just vary the temperature from, let's say, 0 to 100 with step 20. And then click calculate. And as the same, the result will show in this interface. And if we close this one and click the line, it will take the calculated data to plot in here. So in this figure, the triangle is divided by the solubility curve, and the position of the unsaturated region is the upper part of the solid liquid equilibrium curve, this in here. So in the upper part, it will form liquid phase. And for below the solid liquid equilibrium curve, 1 or 2 salt will precipitate depending on the position in the triangular. At the left-hand side, 1 salt will be formed with the liquid solution, and in the opposite way, at the right-hand side, another salt will also be formed with the liquid solution. Okay, so these are all for the demonstration of the property electrolyzation system.
Okay, move to the reactive system features. Another our efficient tool called Process Design Studio will be opened. This function normally consists of 2 types of calculations. The first is standard calculation used in the non-reactive system. And another one is the element-based calculations, which is the reactive system. For the standard calculations, the workflow consists of 4 steps, starting with adding the components, then select the thermodynamics, select the calculation type, then run and calculate. It will show you the result here. This is the result from the water, benzene, ethanol system. The result can be divided into 3 types, which are binodal residue azeotrope calculations, and driving force-based distillation design calculations, and equilibrium-based distillation design calculation here. As same as in the element space, the steps are almost the same, but the type of the calculation can be more than that. And after click running and calculating, the result will be shown. This one, I will give you the result of isobutene, methanol, 1-butene, and methyl 3-butyl ethers. And these are all the 5 calculations, which are reactive bubble point temperature or pressure calculations, reactive TP flash calculations, reactive phase diagram, reactive residue curve, and the column specifications.
Solvents are widely used in chemical industry in many different applications, such as in synthesis, separations, washing, and cleaning steps. Properties of solute and solvents are the keys for establishing the feasibilities of product recovery and separation by crystallization. For each processing, all possible solvents need to be evaluated so that the optimal can be identified and selected for the final verification by experiment, thereby saving resources and time by focusing only promising solvent only. This short video will highlight the basic features available within the toolbox of ProCAPE. In this properties prediction series, we mainly use ProCAPE, which is our especially developed computer-aided properties estimation software tool. In this video, we will highlight the toolbox for solid solubilities with also option for solvent performance evaluation. Let's go to more details on the solid solubilities feature inside. There are 4 features here. Firstly, solubilities predictions. Solubilities diagram of mixtures will be predicted based on the mixture definition and selected model. In the feature of solvent design, if user provides the targeted API, the alternative solvent with design will be evaluated and linked. Then, user can select only match solvent with the requirement and do the validation through experiment. For polymer, the mixture contained polymer can be evaluated. And for the database, API, lipid, and solvent database are available. The processing of solid solubilities estimation has 4 steps, starting with compound selection, which API, solvent, and lipid will be specified. Then, select model, check model parameters before exiting before running, and finally calculate and plot solubilities curve.
I will go to the last part of the features, which are the solid solubilities. This is used for the prediction of the solubilities of pharmaceutical compound in the pure or mixture solvent using the model of KT Unifact, NRTL6, and PCSAF. And the 4 steps of workflow are the same to generate the solubilities curve. And this function will be benefits for the pharmaceutical process. So we will give you the case study of paracetamol to show the software demonstrations.
Okay, so turning now to our last function that I will demonstrate today, which is the properties estimation for solid solubility. So this is the toolbox that provides the solid solubility curve by using a several models like NRTL6, PCSAF, or KT Unifact, along with the solvent and polymer design. So first, in the example, I will compare the calculated solubility curve of acetaminophen in ethanol solvent from several models. So starting from select the API compound as acetaminophen and with solvent ethanol. And then I will just first calculate it through NRTL6. And the parameter that was used for calculation will be shown in here. And then I click calculate. So in this figure, the blue curve is the saturation curve, and at the high temperature above blue line, the the selected compound will form the liquid phase, and at the blue line, the solid will start to be formed at the temperature lower than blue line, the solid will be formed and mixed with the liquid phase. Then I will close this one and try to calculate it through PC Sharp and click calculate it at the same. Okay, so here is the phase diagram by using model of PC Sharp. Next, after we got the result from both models, the button for compare model will be active in here. So we can click and it will compare both two curves from the generated model in this figure. Also the data table at the right hand side. Okay, and then I will close this one. Next, I will add more solvent in here, like acetone, for example, as solvent 3. And then I will select NRTL6. And I will insert the temperature as 300, let's say, and click calculate. So after we click calculate, the ternary curve will be shown in here. Okay. So these are all for the property estimation of the solid solubility.
This was the brief overview of some of the basic features available in ProCAPE related to electrolyte, phase diagram for reactive and non-reactive mixtures, and solid solubilities. If you would like to know more, the manual of ProCAPE gives information of all features available and highlights their use to work out on the tutorials. Please contact us or visit our website for more details on ProCAPE. Please subscribe to our YouTube channel to remain updated on our new addition to BSc for Speed YouTube channel. Thank you for your time and interest to our videos.